Hello, dear students. In the previous lecture of structure of atom, we did the discovery pattern of what subatomic particle like proton, electron and neutron. Second thing, we have discussed the first model, that is your Thomson model of atom. Okay, we studied about that. I told you that the different features about the good features about the Thomson model, that it's a assumption of the neutrality of atom is still working. The second thing, this is the only model which assumed that mass of an atom is throughout distributed. These two things are only present at the Thomson. Now, what is the next model? That gives you Rutherford, because we know that it is not able to solve something, particularly radioactivity at that time, and the other phenomena we discussed, X-rays, okay, phenomena, that why atom are showing this kind of behavior. So a lot of blow through this model. Stability is also not explained. So next model comes is Rutherford's model of atom. It is a practical model. The all models, three other models are theoretical ones. This is one is a practical model. Why? Because it's a all observations, results, whole is dependent on an experiment. This is also known as Rutherford alpha scattering experiment. This model is based on the alpha scattering experiment. Let's see what is alpha scattering experiment. First of all, you have a cavity over here in which you will put a radioactive element. Here is a radioactive. This is a radioactive element. Any heavy element can behave as a radioactive element, dear, like plutonium, uranium. Okay. Mean to say they emit radiation. We will separate alpha radiation only. These are alpha radiations. Okay. So we may alpha radiation to fall on a thin, very thin. Okay. This is a thin gold foil. Okay. So he strikes the alpha radiation on thin gold foil, and around the gold foil he put a screen over here. Okay, this is a phosphorescent screen, particularly screen made up of zinc sulfide, which can spot particularly. So what he observes, that he observes spots particularly. Okay. Over here a little bit more spots, but in this direction the spots are lesser. Okay, because these radiation get deflected and pass through. But only one particularly you will see in this direction. One radiation he will show also in which in both kind direction arrows are shown. Let's see what he concluded from this experiment. What his observation, first thing. So when he did this, he made the alpha radiation to fall in the gold foil and observed the pattern of deflections particularly, or scattering of alpha particles. What he observed first, most of alpha particles passed straight, or you can say 90% almost. They pass straight through the gold foil. Second, almost 9% you can say alpha particles. Okay, or 9.9 you can say 9.9% particles get deflected to small or larger angle. Okay. Third, only you can say rare alpha particle bound back, or you can say bounce back on same path. So these three different kinds of things he observed from the scattering of alpha particles. So now what, on these observation base, he do give some conclusions to you, or you can say his model is prepared by these observations. What is the first conclusion? That most of alpha particle pass straight through the Wolf file. From he concluded mostly space in atom is empty. That's why they pass straight. So mostly space is empty. Even he considered that 90% space is empty in the middle. Second, that 99% get deflected towards the atom. So he assumed that there is negative charge particles which attract the alpha particles and deflection occur. Okay, but third is the most important. The rare particle which rebound, on that he conclude all positive charge in atom is concentrated in center of atom known as nucleus of atom. So on that basis you can simply draw the model of the atom, that this is nucleus in which positive charge and around here are negative charge around circulating in an atom, and mostly space of the atom is empty. So this is the model given by the Rutherford particularly. Okay. So, but this model of atom also get a lot of blows, or many things which is not get explained particularly, like how, what is drawbacks related to it? Let's discuss them. Drawbacks of a Rutherford model. At that time, classical mechanics we used, physics particularly. At that time, classic mechanics is used, mean to say laws of motion given by Newton is applied to microscopic as well, which is not today. Okay. So drawbacks of Rutherford model is that we know that in atom, the attraction force between two particles, charged particles, will be given by K1 by K1 R square, and gravitational force is given by G M1 M2 divided by R square. So if something is, its model is compared with the sun planet system, okay, but if something is moving in circular, it must accelerate. Why? Hence its speed is constant, but it is accelerating. Why it is accelerating? Because direction is changing every second. So if direction is changing, velocity is changing, acceleration is changing. But accelerated charge always emit radiation, particularly electromagnetic radiation like X-rays. Okay. So mean to say energy loses by the electron, and if energy lose, they must fall in the nucleus and the atom should collapse. So mean to say stability of atom is still not explained, is not explained still. Okay, on the model he has given, stability is not explained still. Second thing, spectrums are also not explained. And these many particular things, these are the main reasons which leads to the formation of the next model. Mean to say, experiments led to the Bohr model. First one is dual nature. Dual nature is also not explained. Dual nature of EM waves is not explained. Second, spectrum not getting explained. So that's why we need another model. That's why we go to Bohr model. But today we will discuss about only Rutherford. We discussed that yes, Rutherford did the experiment practically, whole thing. Okay, a lot of things he measured, that mostly space is empty, there is negative charge revolving around, and a positive charge is concentrated at the nucleus particularly. Okay, and you know the limitation as well, that stability is not explained, spectrum is not explained. Okay, and what are the factors leading to the next model? But two terms here are of quite importance, we must know about them. That after getting the nucleus world, which is given by the Rutherford, at the Thomson model there is no nucleus. So we know that in nucleus two words are defined for the elements, that is atomic number. Atomic number is number of proton. Always give the atomic number definition on the basis of proton, not on electron. Number of proton inside nucleus. And suppose X is the element, so always it is written here. I am writing around it with A, atomic number. Okay, then there is mass number. Mass number is sum of proton plus sum of neutrons. Or you can say sum of number of protons or number of neutrons. That is gives you mass number. Let's represent it by Z. So the element whole represented by A, Z here. Okay, both things on the same sides. Atomic number down, Z down. Like for example, carbon is given 6 is atomic number, 12 is its mass number. So in this way, all elements will be represented. Another thing, you know that the definition of isotopes and isobars as well. You must know, I am repeating them. So isotopes having same atomic number but different mass number, because they contain different number of neutrons particularly, and having same atomic number mean to say they have all have same number of proton nucleus, so but different mass number. These are isotopes particularly, for example C612 and C614. So mass number is different, atomic number is same. Now what about isobar? It is reverse, having different atomic number but same mass number. This is possible in case of when you are comparing two different kind of elements, like a calcium 20 will 40. Okay, and if you talk about the argon also, whose atomic number is 18, atoms mass is 14 particularly. So their mass number is same. So we are comparing here in case of isobar two different kind of elements. But in case of isotopes, you are comparing same kinds of atoms, whose mass is different. That is the whole thing about the isotopes, isobar, atomic number, mass number, and Rutherford model. Okay, so today, first thing you will read the topic did. Okay. Second, sort out 10 Qs and their answer, short type. in rough node. Thank you.